Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on November 28, 2025, about 5 days ago. It introduces a dual-branch video diffusion model that jointly generates color frames and depth, and it manages over 40% reduction in camera motion errors compared with prior methods. The paper is titled DualCamCtrl, Dual-Branch Diffusion Model for Geometry-Aware Camera-Controlled Video Generation. And as we will see later, the geometry-aware control it achieves makes camera-driven video generation look far more stable and realistic. Figure 1 gives a visual sense of why this method matters, because it shows how closely each model follows the same target camera path while keeping scenes sharp and stable. The big grid of frames compares the input image, two prior camera control models, the new dual-branch model, and the ground truth videos. Small three-dimensional plots above each sequence depict the intended camera trajectory in space. Across the rows, the dual-branch model tracks that path more faithfully and preserves details, so its results look closest to the real footage. Figure 2 shows how the dual-branch system actually processes an input image and its depth map to make a camera-controlled video. The left side encodes RGB and depth separately into latent space, so each stream keeps its own representation while sharing the same camera path. In the middle blocks, the model repeatedly denoises both streams and lets them communicate through the Semantic Guided Mutual Alignment module, which is a special fusion step that trades appearance cues and geometric cues. On the right, the two refined latent sequences decode into synchronized depth and RGB videos, each supervised by its own loss, so they remain stable and consistent. Figure 3 explains why the Semantic Guided Mutual Alignment module is needed by contrasting different ways of coupling color frames and depth. The left panels show that if RGB and depth evolve independently, their edges and objects drift out of sync across frames. The middle comparison shows that one-way alignment still leaves local areas, like counters and cabinet edges, noticeably mismatched. The right comparison shows that pure geometry guidance makes motion look warped, while the Semantic Guided Mutual Alignment version keeps both geometry and appearance coherent. Figure 5 highlights that the earliest denoising steps matter most for stable camera control. The top left plot shows that similarity between the RGB features and camera pose peaks in early and mid-network blocks, then declines. The top right plot shows that spending more steps in this early stage steadily lowers the video quality metric FVD, meaning better videos. The bottom plots indicate that giving extra weight to early steps reduces variation in this similarity measure and further improves overall quality. Table 1 turns those insights into hard numbers, showing that the dual-branch model clearly outperforms all baselines on the image-to-video task. The left half reports results on the real estate 10K dataset, where the new method achieves the lowest video and image distances and the smallest camera rotation and translation errors. The right half shows a similar story on the DL3DV dataset, with the best or second best scores across most metrics. Overall, these metrics say the model keeps frames realistic, temporally smooth, and closely aligned with the intended camera motion. Table 5 reports how people actually judged the videos, and it shows that the dual-branch model feels best to human viewers. Normalized scores run from 0 to 1, where higher means better. In the image-to-video rows, the method leads every column, especially for consistency and semantic consistency, which means how well the content matches the prompt or source image. In the text-to-video block, it again tops smoothness, visual quality, and overall average. Alright, to wrap up, the key takeaway is that separating color and depth while letting them talk through semantic guided mutual alignment gives far tighter camera control and smoother, more realistic videos. This kind of geometry-aware generation could really stabilize creative tools, virtual tours, and robotic simulation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.